Okay, on the front of this worksheet, we're practicing again with our sequences, and we're looking at them in context, where we're hoping that you can sort of take out the information we need from the little scenario and that you're able to make a table, graph it, and write the recursive and explicit from it. So let's take a peek. Below, you're given various types of information. Write the recursive and explicit for each arithmetic sequence. So we're already being told to expect that these are going to be adding or subtracting some constant rate. Kylie transferred to El Camino. She made 3 new friends on the first day, and her number of friends continued to increase by 4 each day. So let's go make a little table to visualize this. Okay, picture that over here it's the number of days, and here it's the number of friends that she's made. Okay, so it says on the first day, she made 3 new friends. And then every day after that, it was 4 more. So we're just filling in the table there for how it would be 4 more, 4 more than that, 4 more than that. How'd you do? And then let's go write that recursive. We'd say f of 1 is 3. On the first day, she made 3 friends. And then f of n minus 1 plus 4 new friends each day. And the explicit begins with 3 friends, adding 4 friends each day after the first day. Okay, so now that we wrote those recursive and explicits, now let's go graph it. So I can just count on the bottom by 1, 2, 3, 4, 5, right? We're just going up through 4. And on this side, we need to get up to 15. So let's say 15 is somewhere around there. And then let's go graph it. Go put a dot at 1, 3. Go put a dot at 2, 7. Go put a dot at 3, 11. And then 4, 15. And hey, look, it looks linear like it should because we're constantly adding 4 each time. Good job. Okay, the next one is a car dealership that has 180 cars in its sale lot, and it sells 20 each month. So over here is the number of months, and over here is the number of cars. And when it just says that a car dealership has 180, it's kind of like saying at the beginning there were 180 cars in the lot. So this is actually going to be a time 0 function. So it's going down by 20 each time. And so that means right here we're going minus 20. Okay, let's go get the graph ready. 1, 2, 3, 4, 5. And on the side, what if we went by 20s? 20, 40, 60, 81. 20, 40, 60, 82. And then down here, we're going to have number of months as the label. And up here, we're going to have number of cars on the y-axis. Let's go put some dots. Okay, we're going to be starting at 0, 180, way up here. Going down by 20, we're going to go to 1, 160, 2, 140, 3, 120, and 4, 100. And we could keep going in the same pattern, etc. And look, it's a linear pattern because it's going down by the same down 20 each time. My recursive this time says At the beginning, there were 180. So f of 0 equals 180. F of n equals f of n minus 1 minus 20. F of n equals, begins with 180, subtracting 20 every time to the n minus times 0. So you can put a big N minus 0, or you can just put a big N. Do you want to leave the 0 off? You can. It's up to you. However you want to do it. Okay, on the last two, it talks about some geometric sequences. Let's see if we can recognize the difference here. Kylie eventually got really stuck up and her friends could no longer tolerate her attitude. She had 1,024 friends, but she lost half of her friends each week. Okay, so here is number of weeks, and here's number of friends. So it says that she had 1,024 friends. So before we start counting the weeks, that's how many she had. And then each week she lost half. So half of 1,024 is 512. Half of 512, that'd be 256. Half of 256 be 125, 6, 7, 28. Half of 128 is 64. And so on the side, we're going to have to figure out how to scale, because on the bottom it's easier. 1, 2, 3, 4. This is going to be the number of weeks. But on the side, we got to get all the way up to 1,024. So if we go 100, 2, 3, 4, 500, 6, 7, 8, 9, 1,000. So if we count by hundreds, 1, 2, 3, 4, 500, we'd be like that. Okay, and on the side, it's the number of friends. Okay, so here I go. Let's go put the first dot at 0, 1,024. 1, 512. 2, 256. 3, 128. And 4, 64. Notice that curving line that's going down. Let's go write the recursive. F of 0 equals 1,024. F of n equals f of n minus 1 times 1/2. For our explicit, we begin with 1,024 times 1/2 to the power of n, or n minus 0, whatever you want. Now, why is this the little exponent n? Because we need exponents when we're showing repeated multiplication. All right, last but not least, pause the video, try part B on your own. Let's see how it did. Okay. So, Mr. Rotor's yard has weeds. And on the left-hand side, we're going to put the number of months. Okay, so his yard had 10 weeds in the first month, and he didn't take care, so it tripled each month thereafter. So 10 times 3 is 30, 30 times 3 is 90, 90 times 3 is 270, 270 times 3 is 810. Yikes, we're getting up high. 100, 200, 300, 400, 500, 600, 700, 800. On the bottom is number of months, and on the side is number of weeds. So go put that first dot at 1/110. 110, way down here, pretty much touching the axis. 230, still way down there. 390. 270. And then 5, 8, 10. That jump. Look at that growth. So our recursive function is going to go f of 1 equals 10. F of n equals f of n minus 1 times 3. F of n equals, begins with 10, multiplying by 3 every time to the power of little tiny n minus 1. And if you want, go show that times 3 work over on the side. Okay, how'd you